This will be the last section we cover in Chapter 5. This is the Poisson probability distribution. Now, we know that we use the binomial probability distribution to find the probability of getting exactly R successes in N trials. We can use the Poisson distribution to find the probability of getting some particular number of occurrences at some event over some unit of time, area, volume, something like that. Here's an example. We'll get to this Greek letter in just a minute, but here's an example. The mean number of accidents per month at a certain intersection is 3. So what's the probability that in some particular month there will be 5 accidents? So we're over some kind of a time period. And here is the Poisson distribution. Let lambda, all right, now that is right over here. That is a Greek letter lambda. And lambda, that's going to be the mean number of successes over some interval, like time, area, volume, something like that. All right, so we're looking at an interval of time, say. And then let R be the number of successes in that same corresponding interval. Then the probability of getting R successes in that interval is given by this formula right here. Now, that looks a little intimidating, but you may remember from your algebra class that E, that lowercase e, is that number 2.71818 ... and so on. It came up when you talked about natural logarithms. Now, we don't need to get into that. All we need to know is where to find those keys on the calculator. And one more thing about Poisson distribution before we do an example is that the average number, right, the mean for this is going to be exactly lambda, right? That's what lambda is. If you remember back up here, we said let lambda be the mean number of successes, all right? So that's mu is equal to lambda. And then the standard deviation, well, this is just the square root of lambda. Here's an example. According to the Office of U.S. Courts, the mean number of bankruptcies filed per hour in the United States in 2016 was about 2.8. So find the probability that in any given hour there will be 5 bankruptcies filed. So we have a formula. When we have a formula, I like to write that formula right so I have it in front of me. So it's going to be the probability of getting R successes is e to the negative lambda. Now remember, lambda is the average number of successes, times lambda to the number of successes that we want, divided by the number of successes factorial. All right, now we've got everything we need here, right? Lambda is the mean number filed is 2.8. R, we're looking for 5, and that's all we need out of this. So let's just substitute these numbers in and compute. Let's do this on the left side where we got a little bit more room. So we need to get this E right down here. I'm at the bottom right. I need to get that E. Now on my calculator, it is a second function. So what I'm going to type is this. In order to get it, I have to hit second. Now if you look down a ways, you'll see a key. It's like third, not right near the bottom. It says LN. And right above it, it says e to the x. So it's a blue key. Press second e to the x. All right, so second e to the x. And then what you want is negative lambda. Now, you need negative. So hit the negative sign, not the minus sign. Okay, this is not minus. Be careful. Minus is over here, you know, with plus, minus, times, and so on. So second e to the x, second ln. Hit the minus sign, or I'm sorry, the negative sign. So you got that negative sign, and then put in lambda. Now for us, lambda is 2.8. So now you're going to type in 2.8. Now what you want is lambda to the r. So lambda is 2.8, and r is the number of successes that we want, which is 5. So you're going to type in now, just type in that 2.8 again, and then raise it up to a power right above the division sign, that caret key, and raise it to the 5th. Now we need to divide by r factorial, all right? So now you're going to press the divide key. So you press the divide key. But you know that divide key looks like this, but when you actually press it, you get that slash. Now you need that 5 factorial down in the bottom there, right? You need the r factorial. R is 5. So you're going to type in the 5. And now we have to go get the factorial. Well, here's where you're going to get it. You're going to press the math key. Now in the very first column, the math key is like the third one down. So you're going to press math. All right, you press math. And then you want to scroll over to PRB. All right, so you're going to scroll over to PRB, which is probability. All right, so you scroll over there, and then if you look down to number 4, right, item 4, it's got the factorial sign on it. So you can just press the numerical key 4 or scroll down and enter. And that puts you with 5 factorial, right? So you get that factorial sign. And now you are looking at this. If we've done everything correctly, we're looking at this. We're looking at e to the negative 2.8 times, I'll write it like that, times 2.8 raised to the 5th, all of that divided by 5 factorial. And when you press enter, I got 0.0872 dot dot dot. Okay, how about that? 0.0872. Right, so the chances of having 5 accidents at that intersection, that'll happen about, 8.7% of the time, or about 9% of the time. Let's do it straight on the calculator. So the first thing you're going to do is you're going to type second. Second. Let me write that so it's readable. Okay, you're going to type, press the second key, and then you're going to go over here and press the VARS key like we did in binomial. You press VARS because that's where the distributions are. Then you're going to scroll down to C, right? Item C is Poisson PDF. All right, so go ahead and do that. You scroll down, you press enter, right, to actually get it. So you press enter, and then what comes up is this, lambda, x value, and paste. All right, so your lambda, you know what that is. Type in 2.8. The x value, for us, that's 5. So you type in those values, go down to paste, press enter, and then what comes up is this, Poisson PDF, can't really see that there, and you can't actually see the whole thing, but it comes up as 2.8 and 5 and close, and now just press enter. Okay, and right here is that I'm getting that 0.0872. Right, I'm getting the same thing I got before.